Okay, ladies and gentlemen, we're looking at question 15 from section 3.5. It's an achievement check question. Fast food restaurant is running a scratch and win contest. Customers scratch 6 squares on a card and try to match the 6 numbers randomly selected from 1 to 20. They're printed on the top of the card. First prize is awarded if all 6 numbers match, and that's what part A is asking us about. Part B and C are asking us about second and third prize, where you only have to match 5 or 4 of the numbers. So part A is pretty straightforward. We need to find the number of ways that event A can occur in order to find the probability of event A. So the number of ways for event A divided by the number of ways in the sample space. And so the number of ways event A can occur is for you to match all 6 numbers. So 6, choose 6. And the number of things that could happen, well, that's 20 possible numbers from which you choose any 6, which is a significantly bigger number, right? So that would be 1 out of some big number. Let me check my calculator. So it's 38,760. And that's pretty much part A. Part B, on the other hand, Part B is asking us about second prize, which is awarded if 5 of the 6 numbers match. And so we're going to call this event B. The probability of event B is related to the number of ways event B can happen divided by the number of ways in the sample space. The sample space is still, well, I was going to say 38,760, but it's still 20, choose 6. But in the number of ways B can happen, well, that's basically, we're going to say there are 6 numbers. You can choose 5 of them, and you could choose 5 ways. But also we have to consider the non-winning number. So there's 14 numbers that are not winning numbers out of the 20, and we'd have to choose one of those. So 6 choose 5, which is 6, times 14 choose 1, which is 14, so we end up with 6 times 14 over 38,760. So that's 84 over 38,760, which reduces to 7 over 3230. And I'm going to leave it in round form rather than try to convert it to a decimal. It's going to be a very low probability, right? 7 chances out of 3,230 outcomes. Pretty low probability. Okay, so part C is asking about the probability of winning third prize, and third prize is awarded if 4 of the 6 numbers match. So we'll call that P of C, and then we need to calculate the number of ways that C can occur divided by the number of ways in the the sample space. And so that's out of 6 numbers that are winning numbers, we have to choose 4. But then also out of the remaining 14, we must choose 2 that are not winning. So there's 14 ways choose 2 ways that can happen. And we're going to divide by 20, choose 6, just like we have been all along. And so 6 choose 4 is 15, and 14 choose 2 is 91. Over 38,760. There are significantly more ways that this can occur. 1365 over 38,760. Or we can reduce that as well. So that reduces to 91 over 2584. So let's see now, we're looking at roughly 100 out of 2600. So yeah, somewhere in the range of 3 or 4% of is your probability of winning third prize. In fact, if we want to look at the relative probabilities, 1,365 ways to win third prize out of the full 38,760. There are 84 ways out of 38,760 for winning second prize, and there's one way for winning first prize. It's very rare that someone will win first prize in this contest. Part D, what are the odds against winning a prize? Well, in order to know the odds against anything, we have to know how many ways it can happen and how many ways it cannot happen, right? So we're going to look at Part D now and say that the number of ways that event, I guess we'll call event D A plus B plus C, and then we need to look at the ways it cannot happen compared to the number of ways that it can happen. So there's obviously a total of 38,760 different things that could happen. 1 plus 84 plus 1365 is N of D. So we're gonna add those all up. So the number of ways you could win would be 1,450 ways, and the number of ways you could not win, the number of ways that you, I don't know if you call it losing, but anyway, not winning. So that's 38,760 minus 1,450. And so that works out to the vast majority of the time, 37,310 ways of not winning. And so the odds against winning would be 37,310 compared to 1,450. And we can certainly divide by 10 and we get 3,731 compared to 145. I don't think that reduces any further. Although I suppose we can just think of it as 25.7 to 1. Those are the odds against winning. So, yeah, pretty low odds. Pretty bad odds. Predict the number of fast food meals a person would need to buy in order to have a relatively good chance of winning a prize. You think this strategy is sensible, and why? Well, I guess I'd need to know how big the prize was to decide if that was sensible. But anyway, and this is kind of an open-ended question, because what exactly does it mean by a relatively good chance of winning a prize? I mean, maybe if you define that as being a 50% chance or something like that, then you could work out how many tickets you'd have to purchase. But basically, if you bought, let's say, 26 meals, you would have a pretty good chance of winning. But because the odds are 25.7 to 1 against. But anyway, that's sort of an open-ended question. I'm going to leave that one alone. Hope the rest of this helps.